All right, hi folks, hi everyone. All right, folks, we'll get started in just a few minutes. Folks, again, we're going to get started in just a couple of minutes, just waiting for a few other folks to join us. And then we can get started. All right, folks, why don't we get started? Thank you for joining. I hope the audio is okay. I'm using a different microphone today, so I'm hoping the audio is okay. All right, folks, so we are here April 13th. So notice we only have a couple of weeks left in the course. This week and next week, we'll wrap up chapter 10. And then you could see the week of April 27, we're just going to do a review for the final exam. All right, and I'll be giving you more details on the final exam later this week. So I'll be explaining how the final exam will work. But just to let you know, you'll be taking the final exam in WebAssign, just like you've been taking these other tests in WebAssign. Okay? All right, folks, so we'll finish up section 10.3 today. Then Wednesday and Friday of this week, we'll cover section 10.4. Then this Sunday, the homeworks are due for sections 10.3 and 10.4. Now remember, all of these homeworks are kept open until May 1st with no late penalties. But I'm noticing some students are falling a little behind. So please don't, postpone these homeworks unless you absolutely have to. Okay? All right, folks, anyone have any questions on chapter 10 so far? And remember, you can ask questions using the chat or using your mic. And let me just make sure that everyone's mic is enabled. Yep, so everyone's mic should be enabled, so please ask questions.
Hello.
If you would like. Hi, Gennaro, we're just getting started. Thanks for joining. All right, folks, so let's revisit polar coordinates. Let me give you a quick reminder.
I already got 10.3 and 10.4 done on WebAssign.
Nice work, Gennaro. Thank you for working ahead like that. Folks, let me give you a quick reminder of what polar coordinates are all about. And then today, we just want to talk about how do you convert from one coordinate system to the other. And really, it's going to boil down to a couple of formulas that are listed in the chapter 10 summary. Okay? All right, so here was the idea. Take this blue dot. This blue dot can really be located one of two ways. I could write it in XY coordinates. So if I went horizontally X and vertically Y, that would get me to the blue dot. So I could write it in XY format. And you've done that in algebra for many years. Thinking back to your math career, you're a veteran of writing in XY coordinates. But what's new is instead of writing it as XY, we're going to write it as r comma theta. What that means is ask yourself, what angle would you rotate in order to get from the origin to that blue dot? And then how far would you have to travel on that straight line distance to get to that blue dot? All right, so theta is the angle of rotation. R is the straight line distance. All right, and the reason we want to be able to use polar coordinates is in a lot of applications, polar coordinates is much more efficient and makes the analysis much easier versus working in XY coordinates. All right, so let me just give you another quick reminder of what we already talked about. When you want to graph a point on this new graph paper, okay, so we're using this polar grid. Let me actually jump to a WebAssign example that we did. When you want to graph a point on this polar grid, what you have to keep in mind is this is a new kind of graph paper. Each one of these wedges or these sectors is 15 degrees. So when you rotate an angle, keep in mind that each one of these small pizza slices represents 15 degrees of rotation. And then you'll also notice there are these concentric circles that are labeled with the R values. So in this example, they asked us to plot an R value of 3.5 and an angle theta of 5 pi over 3. You might remember this was the same as 3.5 comma 300 degrees. Let's just work in degrees here to make it a little easier to navigate on this polar graph paper. All right, so the way you did this then is you rotated 300 degrees. So let me figure out that rotation. Well, I know this axis here is 270. Let me label this vertical axis here is 90 degrees. This horizontal axis is 180. So to go 300 degrees, I would have to rotate 270, but then I still need to go another 30. Well, notice each one of these slices is an extra 15. So that means I'd be going an additional 30. 30 plus 270 is 300. So this rotation is 300 degrees to get to that black dot. Then you've got to walk out on this red line. Here's a red line. You've got to walk out a distance of 3.5. Well, that means you can use these concentric circles, right? This circle is R equal 3. If you can see it. Let me erase this here to make it a little easier to see what I'm drawing. So this R here is R equal 3, and this circle is R equal 4. So this black dot is a distance halfway between to give us the R value of 3.5. Okay, and by the way, just to give you a little preview of converting, you know, if I was going to convert this black dot to an XY coordinate, imagine changing this scale to XY. So if I was going to think about this black dot in XY coordinates, I would know that to go horizontally and vertically, right? If I was to eyeball this, I would say the X comma Y values, you know, if I'm going out X, it looks like I'm just going to eyeball this. It looks like the X value might be about 1.5 and the Y value is going to be negative, right? Because I'm going vertically down. I'm going to say -4. I'm just making up some numbers here. My point is that when you have a black dot like this, you'll be able to do a sanity check when you convert it to XY, because I could see from the location of that black dot, the X value would have to be a positive number, but the Y value would have to be a negative number, right? Because I'm going horizontally to the right, but then going down vertically. So you could do a kind of a sanity check on your answers when you do these conversions. Okay? And what if I gave you the same kind of black dot? Oh, let me make it a black dot, sorry. Let me give you the same kind of black dot. I'm just trying to give you a preview of what we're going to talk about in just a minute. I'm going to put a black dot here. And let's say this black dot, and now I'm going to give you the XY coordinates. So let's say this is the XY. And let's say this is an X of 2 and a y value of -3, let's say.
Mhm.
So this is an xy of -2, 3.
Mhm.
All right, well, let me try to just estimate roughly what the value of r comma theta is for this point. Remember, this is right now in xy coordinates. So I'm noticing that this rotation would have to take me into the 4th quadrant. So I know r would have to be a value somewhere between 270 and 360 degrees, right? Because if that black dot is sitting in the 4th quadrant, it's got to be some value between 270 and 360. I'm just going to make up a random number. I'm going to say it's 330 degrees. Again, I just made that up, but I just wanted to give you an example where theta must be in the 4th quadrant. And r, I could see, is going to be a value of somewhere, I'm just going to make up a number of like 3.5, let's say. We'll figure out how to come up with these exactly. But if I came up with an r value of 10, right, an r value of 10 really wouldn't make any sense, because remember, the r value is this distance. So that would make no sense. If I came up with a theta answer of, let's say, 60 degrees, well, that would make no sense, right? Because I know the black dot is in quadrant 4. So again, we'll try to do these sanity checks on our answers when we do some conversion examples coming up. All right. So why don't we go ahead then and move to, does anyone have any examples on these plotting questions from WebAssign? All right. So folks, how about if we talk about these conversion equations? All right. What if you're given a polar coordinate? So you're given some kind of r theta value, but you want to convert it to xy. So you're given r comma theta, you want the x comma y coordinates. Well, it turns out this conversion is going to be pretty easy because here are the formulas that you're going to use. I'll circle them here in red. If you want to know the x coordinate, just take r times cosine theta. If you want to know the y coordinate, take r times sine theta. Now, these formulas are not that mysterious because they really just come from the definition of cosine being adjacent over hypotenuse. And you remember the definition of sine is opposite over hypotenuse. So if you look at this little diagram here and you ask yourself, what is sine theta? Well, sine theta is opposite, which is y, over hypotenuse, which is r. So that's where this formula comes from. It's just opposite over hypotenuse using this diagram. Then just cross multiply. If you were to cross multiply this fraction, you would end up with this formula y equals r sine theta. All right, so let's go do some examples to see how to apply these conversion factors, okay? All right, how about if we look at this example here? All right, it said convert this polar coordinate 2, 30 degrees into xy rectangular coordinates. By the way, folks, you might see in WebAssign that when they write x comma y, sometimes they call this rectangular coordinates, but also sometimes they call it Cartesian coordinates. And these mean the same thing. So Cartesian coordinates just mean rectangular coordinates, which just means x comma y notation. All right. Well, let me just give myself a little bit of a sanity check. I know I want to write the xy coordinates of this red dot. So here's the red dot. Well, I know I would be going over to the right horizontally and up vertically to get to that red dot. So I know my answer has to be a positive x and a positive y, right? Because this point is located in the first quadrant, which means I would go over to the right and up. So I know I better come up with positive x, positive y. All right, let's go to the next slide and just plug in. If I want to know the x value, all I have to do is work out r cosine theta. So that's going to, remember, our polar point here was r equal 2 and theta equal 30 degrees. So this is going to be 2 times cosine 30. Go to the unit circle. Cosine 30 is the square root of 3 over 2. And I'm noticing here, this 2 will cancel out with that 2. So the x value here is the square root of 3. You know, if I was to round that to an approximate answer on my calculator, the square root of 3 is about 1.7. All right, let's figure out the y value. Well, y is r sine theta. So that's going to be 2 sine 30 degrees. But from the unit circle, sine 30 is 1/2. Again, the 2's cancel out, so the y value is 1. So here are the coordinates in xy. Square root of 3 comma 1. Remember, approximately, this is like 1.7 comma 1. And if I look at the graph, that does make sense. If you notice, the x distance looks like it is about 1.7, and the y distance is 1. So my answer makes sense when I compare the location of that dot, that red dot, to an xy coordinate graph, for example. Okay, so again, all you need are these two formulas. Remember, this is when you want to come up with the xy coordinates if you're given r comma theta.
For the regular coordinates are square root of 3 and 1a, or you wrote a 2 next to the 1.73.
I'm sorry, Gennaro, that was my poor writing here. Let me clear that up. This was really supposed to be the number 1. Okay.
Okay.
By the way, folks, I'm coming up with a better way to write on these slides. So hopefully by next class, I have a better way to write, because now my handwriting here is kind of sloppy. It's even worse than when I write on a board, when I write on these slides. So I think I'm going to come up with a better way to do this by next class. So bear with me on that. Let's do one more example. How about this example? Let me clear the screen. All right, so this one says, what about converting 5 comma negative pi over 4 into xy coordinates? All right, well, the messy part about this is the angle they're giving me is negative. But I usually don't like to work with negative angles. Let me work instead with positive angles. So remember, when they give you a negative angle, they're just telling you the rotation is clockwise. So this rotation here was negative pi over 4. But instead, let me determine the rotation going in the positive direction. Well, the way I can figure that out is either stay in radians. So I'm going to call this angle theta that we want to figure out here. Well, if I want to know theta, I know the whole rotation around the circle is 2 pi. But to find theta, I really have to subtract out this angle, pi over 4. Remember that negative sign in front of the pi over 4 is really just telling me the direction of the angle. The magnitude, the angle itself, is pi over 4. The negative sign is just telling me it's rotating clockwise. All right, well, if I want to figure this out, let me change 2 pi to have a denominator of 4. Remember, when you subtract fractions, you have to have the same denominator. So I'm going to multiply this 2 pi by 4 over 4 in order to get the denominator I want. So now I'm going to end up with 8 pi over 4. Subtract pi over 4.
It'll be 7 pi over 4.
Yep, so I'm going to subtract the numerators. I'm thinking of this as 8 pi, subtract 1 pi. That's 7 pi. And on the bottom, I have 4. So 7 pi over 4 is the angle theta. Okay. Now, what if you don't like working in radians? What if you prefer to work in degrees? Well, if I work in degrees, I could do the same calculation. I know the full rotation is 360 degrees. And I also know that when I change pi over 4 into degrees, it's 45 degrees. So let me work out 360 subtract 45 on my calculator. That works out to be 315. So I could also use the angle 315 if I wanted to work in degrees. All right, let's go ahead and figure out the x and y values, okay? By the way, folks, I just noticed there's a typo on this slide. This x here should really be a y. So I'll have to fix that on the slides. All right, let's do the x value first. Well, the x value is r cosine theta. So the r number for us is 5, and our theta we figured out was 7 pi over 4. Of course, I could write this as 5 cosine 315 degrees if I wanted to. And if you go to the unit circle and look up cosine of 315 or cosine of 7 pi over 4, you'll see the cosine is square root of 2 over 2. So this answer turns out to be 5 square root of 2 over 2. All right, how about the y value? Well, the y value is 5 sine theta, or I could say 5 sine 315. But the sine of 315 is negative square root of 2 over 2. Multiply it by r, which is 5, and I get negative 5 square root of 2 over 2. So here are the answers written in XY format. Let me do a quick sanity check on my answers here. First of all, do I have the correct signs, positive, negative? Well, I notice for me to get to this red dot, I would have to travel horizontally to the right, but then vertically down. So it makes sense the x number should be a positive number, but the y number should be a negative number. So it looks like the positive negative aspect of my answers makes sense. Also, let me just see if my numeric answers make sense. If I work out 5 times the square root of 2 over 2 on my calculator, I get an answer of about 3.5. So if I was to write this as an approximate answer, it would be 3.5 comma negative 3.5. Does that make sense? Well, if you notice on this polar coordinate grid, let me see if I can mark the R numbers here. This would be R equals 2. This is R equal 3, and this is R equal 4. And I notice that the location of this red dot is at about 3.5 positive and negative. So again, it looks like my answer makes sense when I think about its location on an XY coordinate system. All right, let's also look at some WebAssign examples. Okay, so let's do these WebAssign examples. Let me go up to the top example. It says convert to Cartesian coordinates. Now remember, when it says Cartesian, it's really just asking you to convert to XY. So they're asking you to come up with X comma Y. You can kind of see that in the answer box. Notice the way they say they want X comma Y here. All right. Let me also bring up the unit circle, by the way, just to help us out. Let me, bear with me one second. Let me go to the unit circle. I'm going to go to the chapter 9 summary. So I think the unit circle is there, just to have it with us. Oh no, it's not there. Okay, let me go to the midterm reference. I know the unit circle was there. All right, so we have the unit circle here. Okay, and let me go back to the WebAssign problem. All right. And there we go. All right, hopefully you can see these side by side. So let's take a look here. It says, convert this R comma theta value into X comma Y. All right, well, here are the formulas. X is R cosine theta. So let me just plug into this formula. The R number we have is 9. And then I want to work out cosine of 5 pi over 4. So I could convert 5 pi over 4 into degrees if I wanted to, but turns out the unit circle has radians for the angles, so I could just go to 5 pi over 4. You might notice here it is. Here's the angle 5 pi over 4. All right, I want the cosine, and the cosine is the first number here. So the X value is going to be 9 times negative square root of 2 over 2. Okay, so here's that answer. The Y value is going to be 9 times sine 5 pi over 4. Again, I'll go to the unit circle for that. And it looks like the cosine is also negative. So it looks like the Y value is going to be the exact same answer. 9 times negative square root of 2 over 2. Okay. And remember, folks, because WebAssign is not telling you to round to 2 decimal places or round to 3 decimal places, that's how you know to leave your answer in the form of a square root. Because if there's no rounding instructions, you would not know how many decimal places to round. So just leave your answer using square roots. Let me apply a sanity check to my answer. I'm coming up with an x value that's negative and a y value of negative. That's negative. Does that make sense? Well, for this angle, 5 pi over 4, notice it puts me in the third quadrant here. So if I'm in the third quadrant, it makes sense that to get to that point in an xy kind of manner, I'd have to go to the left for x and go down for y to get to that point. Of course, going to the left for x means a negative x. Going down for y means a negative y. All right, let's do the bottom example then. The bottom example is a little trickier because it has a negative angle. So again, I'd like to maybe get rid of negative angles if I could. So let me go ahead and take the negative angle they're giving me and convert it into a positive angle. All right, so the angle they're giving me down here is, so our R value here is 4, and our angle theta is negative 5 pi over 6. All right, let me change that into a positive angle. Well, the angle we want is going to be 2 pi minus 5 pi over 6. Again, because if you think about it, the angle they're giving us is negative, right? So this is negative 5 pi over 6. But we'd like to know the positive rotation to get to that same angle. So we want to figure out this blue angle. All right, well, I need the same denominator if I'm going to subtract. So let me go ahead and multiply this first fraction times 6 over 6. That means our angle is going to be 12 pi over 6 minus 5 pi over 6.
That's how we get 7 pi over 6.
Yep, that's it. So keep the denominator the same. So our angle that we want is 7 pi over 6. All right, so we know we're working with this angle right here, 7 pi over 6. All right, so let's go ahead and convert. X is R cosine theta. In our example, our R number was a 4. And we want cosine 7 pi over 6. So that's going to be negative square root of 3 over 2. But I can simplify this fraction because I have a 4 on top divided by a 2 on the bottom. So that looks like the answer is going to be negative 2 times the square root of 3. And you can see the answer here in the green box. All right, let's do the y value. Y is R sine theta. All right, so that's going to be 4. And I need the sine of 5 pi over 6. But I could see that sine value is negative 1/2. So 4 times negative 1/2. But that's just negative 2. So the answer here is the xy pair of negative 2 square root of 3 comma negative 2. Again, it makes sense that both my answers, both the x and y values, should be negative, because the location of this angle puts me in quadrant 3, and I would have to go to the left for x and down for y, which means negative for x and negative for y. All right, folks, how about if we look at the other conversion? What about if you want to go the other way? So now, what if you're given the x comma y point, and you want to find r comma theta. All right, well, again, I could use, the fact that this is really a right triangle. So if I want to know this r number, well, really, I can use Pythagorean theorem, right? Because remember, I'm going to be given x and given y. Well, that means I could just use r squared equals x squared plus y squared. Then, once I know r, I can really figure out theta in a couple of different ways. Well, I know that sine theta is y over r. Remember, opposite over hypotenuse. But now I know the y value because that was given in the problem. I just calculated the r value using Pythagorean theorem, so I could figure out the angle theta because I know both y and r. I could use cosine theta if I wanted to. Cosine theta would be x over r. Again, I would know the x value. I figured out the r value, so I could use cosine theta to figure out the angle theta, or could use tan theta. I know the y and the x, those were given to me in the problem, so I could use any one of these three trig functions to find out theta. I'll get the same answer no matter what, so it's really up to me to use whatever trig function I think is the easiest to work with. All right, so why don't we go do a few examples to work through these. How about if we do this example here? So they're giving us that the xy point is 4, 4 here. And you might say, well, how do you know that 4, 4 is xy? How do you know it's not r comma theta? Well, first thing I notice is they're telling me in the wording of the problem, it says it's given Cartesian coordinates. So I know when they give me 4, 4, they say Cartesian, I know that means the x value is 4 and the y value is 4. All right, let me help myself out by plotting this point. I don't have to do this, but I'm going to do it just to give myself a little bit of a sense of where this point is located. Here's 4 horizontally, here's 4 vertically, so this is the point that I'm interested in. But remember, I want to know what is the theta, what is this angle, and also want to know what is this r distance. All right, let's figure out the r first. It's better to figure out r to begin with, because then once you know r, you could use r if you wanted to figure out theta. All right, well, let's use this formula. It says r squared is x squared plus y squared. And again, I could see that makes sense to use that formula because I could draw myself a little right triangle here. So here's a right triangle. The bottom leg is 4. The vertical leg is 4. So r is really the hypotenuse of this triangle. So r squared is x squared plus y squared. But that's going to be 4 squared plus 4 squared. 4 squared is 16, so that means r squared is 16 plus 16.
32.
32. And of course, I want to figure out r. So let me take the square root of both sides. Normally,
the answer is 4 square root of 2.
Yep. So normally I would put a plus or minus in front when I take the square root of both sides like this. But in this example, I know r is a positive number. Remember, they said here r should be positive. So I'm just going to use the positive square root. Now, I could leave the answer as the square root of 32. That would be okay. But you might notice WebAssign is showing the answer as 4 square root of 2. Well, what they did there is they just simplified this square root 32. The way you do that is take 32 and rewrite it as 16 times 2. And the reason to do that is we're trying to expose this perfect square of 16. So by rewriting 32 as the multiplication of 16 times 2, I'm now allowed to break this up into two separate square roots. So I'm allowed to rewrite this as the square root of 16 times the square root of 2. But of course, the square root of 16 is 4. So I'm ending up with r equals 4 square root of 2. So I know this distance is 4 square root of 2. All right, so now the only thing left is to figure out the angle theta. All right, now there's a couple of ways I could do this. Remember, I could use the sine, the cosine, the tangent. Well, one thing that might make this a little easier is I'm noticing the x and y values are exactly the same, right? So the x and y value happen to be equal to each other. So let me try out tan theta and see if that leads me anywhere.
Yeah, potentially you have to do 4 over 4 you have to do.
Exactly right. Yeah, Gennaro says if we write this as y over x according to the formula, right, tan theta is y over x, but that's just 4 over 4.
You just get 1 as the answer.
Which is 1. Now I need to know what angle has its tangent equal to 1. Well, remember, tangent is sine over cosine from its definition. So if the tangent is equal to 1, it must mean the sine and the cosine are the same value. So I'm looking for where the sine and cosine are the same value. The only angle in the first quadrant where that's true is 45 degrees. Because notice sine and cosine are identical here. So the answer is going to be the angle theta is either 45 degrees, or we could write it as pi over 4 in radians. Okay. By the way, folks, remember, it's a good idea on your copy of the unit circle to write down the tangent for each one of these angles on the unit circle. It's a big time saver. And to figure that out, you would just take the sine divided by the cosine for each one of the angles, and you can write that in pencil on your version of the unit circle. Folks, any questions so far on doing these conversions? All right, folks, let me talk about one last item to wrap up, and we'll finish this up more on Wednesday. Here is what we'd like to be able to do. What if we want to take an equation and convert from rectangular to polar? Okay, or the other way around. Well, imagine I give you some kind of an equation that only has x's and y's in it. I want to change that into a polar equation. That means you would have to get rid of the x and y's in the equation and only have, so you'd have to get rid of x and y's, and your final answer should only have r's and thetas in it. So your answer is going to be r equals something. Let me give you an example. Maybe I'll end up with r equals 7 plus sine theta. Notice this answer only has r and theta in it. There's no x's and y's. So when you convert from rectangular to polar, your answer should not have any x's and y's in it. Well, the way you're going to do this is just use these different substitutions that we've been working with. So use these formulas. Anytime you see an x in the equation, replace it with r cosine theta. Anytime you see a y in the equation, replace it with r sine theta. If you happen to see x squared plus y squared in the equation, you can replace that with an r squared. All right, so you're going to be doing some detective work And anywhere you see an X or a Y, you'll try to replace it using these kinds of equations. Let's do a couple of examples. And maybe we can go to let's go to WebAssign, but how about if we do, let's do a quick example here just to see how these substitutions work. All right, here's the equation they're giving us. X squared plus y squared equals 6y. And remember, they're telling me rewrite this as a polar equation. So I've got to get rid of all x's, all y's, and end up with only r and theta in my final answer. First thing I notice is on the left side here, I'm seeing x squared plus y squared. Well, I know there's a formula that says x squared plus y squared equals r squared. So I'm just going to replace this with r squared. And on the right-hand side, I'm seeing a y. But you might remember there's a formula that says y equals r sine theta. So I'm going to replace this with an r sine theta. And really, this is a valid answer because I've gotten rid of all the x's and y's. That was my goal. There is one simplification, though, that I could do here. Because I have an r on both sides of the equation, what if I divide both sides by r just to do some simplifying? Well, on the right side, the r on top would cancel out with the r on the bottom. On the left side, r squared divided by r to the 1 is just r. So I end up with r equals 6 sine theta. Okay, and so that's the final answer because my answer only has r and theta in it. All right, maybe we could do a WebAssign example. And you might say, why do you want to do this? What's the point of this? Well, in many cases, when you're doing some analysis, let's say, for example, in calculus, you might be finding things called derivatives or integrals. And it might be a lot easier to do that analysis if the equation was written in polar form instead of XY form, or the other way around. So there's some examples where doing this kind of conversion from either rectangular to polar or polar to rectangular simplifies the analysis considerably. So that's why we want to be able to do this. All right, folks, let's do these examples quickly. This is actually similar to what we just did, but let's do it anyway. On this first example, I'm noticing this is r squared on the left side. And on the right side, it's 4y. But remember, y is r sine theta. So I'm going to replace the y with r sine theta. Now I'm noticing that I can simplify by dividing both sides. Let me write that again. Dividing both sides by r. So I'm going to divide both sides by r. And it gets me the final answer, r equals 4 sine theta. Okay, and remember that your answer should only have r's and thetas in it, no x's and y's. By the way, what if you forgot that r squared was equal to x squared plus y squared? What if you did this problem a different way and you said that x was r cosine theta So you said x is r cosine theta, and you said y is r sine theta. I just want to show you that you could also do it this way. So you replaced x with r cosine theta, you replace y with r sine theta. Well, if you did that, this is going to be r squared cosine squared plus r squared sine squared. I'm just working with the left side of the equation right now. But I could factor out an r squared here. And that would leave me with cosine squared plus sine squared inside the parentheses. But an alarm bell is going off because inside the parenthesis is the famous sine squared plus cosine squared, which is 1. So this is just r squared times 1, which would just be r squared. And of course, we knew that because when we saw x squared plus y squared, we replaced it with r squared. Okay? All right, folks, I think we're out of time. So let's do a few more of these examples on Wednesday. And then Wednesday, we'll also get started in section 10.4 on graphing these polar equations. All right, folks, any questions? All right, if there's no questions, feel free to log off. Thanks for joining. I'm going to stick around for a few minutes, so if you do have a question, feel free to stick around. Otherwise, I'll see you on Wednesday. And please try to get started in this 10.3 WebAssign homework. Thanks, everyone. All right, folks, if there's no questions, I will close out the class. Thank you, everyone, for joining.